Hi guys, we're going to be talking about solving absolute value inequalities today. So instead of an equal sign, you're going to see like a less than or a greater than symbol. And to get you started, you're going to need to take notes today, very careful notes, okay? Because this is kind of tricky when you first get introduced to it. And I have a format that I want you to use to structure how this is going to look. So we are going to have two columns where we talk about how things look if you have a less than sign and how they look if you have a greater than sign. And they're very different cases. Then in the middle, I'll list some steps that you're going to do no matter which type you have. And then we will do a specific example of each of those. And lastly, we'll look at some weird cases, some unusual stuff that can happen when you have absolute values. Okay, so that's the structure. The reason I wanted to show it to you is because I don't think I have enough room to do those two columns up here all at the same time and keep it big enough that you can read it on screen. So I will write a part and I'll tell you which section we're working on here, and then I'll press pause and erase it so that it's big enough for you to actually see. So that's what I'm thinking with this. Okay, so let's get started. So this first bit here is going to go in less than. So go ahead and set up your page like this. It's chapter 2.3, solving absolute value inequalities. And we have less than and greater than. So we're going to start over here with less than, okay? Okay, so I told you we were going to be using Lila, the less than dog. So she's going to come into this here. So let's say that we have the absolute value of x is less than, or I'll say less than or equal to 5. So here's what that is going to mean. So here is Lila's chain. Let me get her attached here. So here's her doghouse. She is anchored at the origin. The reason she's anchored at the origin is because when we talk about absolute value, we're looking at distance from 0. Okay, so that's where she's tied up. And in this problem here, it says we want the absolute value of x to be less than or equal to 5. So what that means is she's going to stay within 5 feet of the doghouse. Her chain is 5 feet long. So if her chain is 5 feet long, she can walk around here. She can get to the number 2. She can get to number 3. She can get to 3.5. She can get to 5. She can get to 4. She can get all the way up here to the 5. But that's all the farther she can go because that's where her chain ends. That's all the farther she can go to the right. But she can also walk over this way a little ways. So she can come down this way. She can walk to -2. -3, -4, but -5 is the farthest she can go because that's all the longer her chain is. So if she's going to stay less than or equal to 5 feet from 0, she's got a 5 feet long chain, and that's where she can stay. Oops. Nope. So this is where we are talking about Lila, the less than dog. So hopefully you can see her picture there. You could draw a little sketch of a dog. So her distance will stay within 5 feet. So that would have whatever's in here. And as we get to other examples, it'll be a little bit more complicated than just an X in here. I'm just starting kind of simple so you get an idea of this. But that's going to stay in between the -5 and the 5. The farthest she can go to the left is -5. The farthest she can go to the right is +5. So she's going to stay within those numbers. Those are the numbers on the number line that she can reach. So if you're within there, she could bite you. Okay, that's her area, her yard, I guess. Okay, So that's less than. If I was graphing this on a number line, -5 to 5 is the area that is solutions to this equation. So I would color in the section between the -5 and the 5. There. Now let's talk about greater than. So this absolute value means what again? Distance from 0, yes. So we are looking at a distance from 0 that is more than 5 units. So I want to say more than 5 feet away. So this is going to be about Guy, the greater than guy. So Guy wants to stay more than 5 feet from the doghouse. Okay, so here's Guy. Why does Guy want to stay more than 5 feet from the doghouse? Well, because he doesn't want to get bit by this ferocious dog. So he has to stay more than 5 feet away from where she is chained. That's at the origin, so that he doesn't get bit. Okay, so let's see where he can go. All right, so is it safe for Guy to go right here at the origin? No, he's going to get bit if he goes there. That's not good. So where can he safely stand on this number line down here on the left end? Well, if he's standing down here at, like, we'll put him at -6, can the dog reach him there? Nope. How long's the chain again? Do you remember? Yeah, it was 5 feet, right? So she can go down to -5, but that's all the farther she can go. Is he safe if he's standing down here at -7? Ooh. Sorry, Lila. There. Or -8 or -9 or whatever. Yeah, he can stand down there. Now, if he's really brave and feeling like taunting the dog, how close can he get? Is it okay for him to stand at -5.5? Yeah, he's getting a little risky there. Can he go up to like -5.1? Yeah, as long as he stays just a little bit on that side of the 5, she shouldn't be able to reach him. Okay, so he can stand anywhere to the left of the -5. So one safe zone for the Guy is that he can stand to the left of -5. Whatever's in our absolute value, which it'll get more complicated in our next examples, can be to the left of -5. Or he has another safe zone that he could be in on this number line. Is there somewhere over here on the right that he could safely stand? Well, as long as he stands on the right of the 5, he would be safe down here. So our ferocious attack dog can't get him if he stands to the right of our 5. Let me take her down here. Okay, so here they are. She wants to bite him. He doesn't want to get bit. So he is going to stand in one of the safe zones away from the doghouse. Here's one of the safe zones. He can stand to the left of -5. The other one is that he could stand to the right of the +5. Notice I put the word or in between those because either one of those is an okay place for him to stand. If he's standing over here at the 13, he's fine. He's not going to get bit if he's standing on 13 because the dog's chain is only 5 units long. So that's the difference between less than and greater than. If you're talking about a less than symbol, you would be talking about where the dog can go. They have to stay within so many feet. That's the farthest out they can go. But if you're talking about greater than, you'd be talking about the Guy. Where does he need to stand to stay away from that region where the dog is. So that's the difference in greater than or less than. Okay, so as far as our notes, we are now ready to do the steps section that you're going to follow when solving these, and then we'll look at some examples. Okay, so I have that set up here for you. So let's start with the less than example. So I have the absolute value of 2x plus 3 minus 1 is less than 6. So the first thing that I noticed about this problem is that I don't have the absolute value by itself on one side of the inequality, just like we talked about when solving equations. You want to have that absolute value by itself first before you ask yourself, what does absolute value mean? Distance from 0? Okay, so I need to get rid of this plus 1 somehow. So the first step is get absolute value by itself. So I need to have this absolute value here, the 2x plus 3 absolute value, without the minus 1. So how do we get rid of that minus 1? Well, to get rid of a minus 1, you have to, subtract. Add 1. Sorry about that. Add 1. And I've got to be fair and do that on both sides to keep it balanced. So we will have the absolute value of 2x plus 3. Bring down my less than sign, and that would be 7. Okay, so absolute value of 2x plus 3 is less than 7. So absolute value is talking about distance from 0. We want to stay less than 7 feet away. I need to stay within 7 feet of the origin. Who are we talking about here? We talking about Lila, the less than dog? Or are we talking about Guy, the greater than guy? So yeah, it's about Lila. Okay, so where can she run if her chain is 7 feet long? That's kind of what this is talking about. Now, if you notice, this part of the absolute value is a little more complicated than we did in our intro example. So I'm gonna cover it up for a minute, just so you can think about it as like this stuff, whatever's inside of there. So there it is, all that junk. Okay, there's lots of junk inside of there. So that junk has to stay within 7 feet. So if Lila is up here on her chain, and her chain is 7 feet long, where can she run? Well, how far to the right can she go? She can go all the way up to the 7, and she can go all the way down to the negative 7. But she can't go beyond those boundaries because that's all the longer her chain is. So we are going to write this as okay. Whatever's underneath here needs to stay in between the 7 and the negative 7. Okay? Whatever's in between or inside here, all this junk we're going to see needs to be, needs to be between the negative 7 and the 7. That's how you stay within 7 units. Keep the dog within 7 units, 7 feet, you could say, of that origin. So we have under this, my pink square that fell off, we have 2x plus 3. So I got to keep solving. I need to get that x by itself. So notice I no longer have the absolute value signs here. I've taken care of that because I've looked at the two boundaries on where this can go. It can go up to 7 and down to negative 7. But now I need to solve this and get the x by itself in this middle part of this sandwich inequality. So let's get rid of the plus 3. How do you get rid of plus 3? Well, you minus 3. So that would be negative 10 is less than 2x is less than 4. Okay, let me move that. Oh, I'll squeeze it on down here. Now I need to, my x is still multiplied by 2, so I need to get rid of that. So I'm going to divide by 2. I have to divide all of my sections by 2, all 3 parts to this. So those 2's cancel. Negative 10 divided by 2 is negative 5, so we would have negative 5 is less than x is less than, and 4 divided by 2 over here on the right, that would be 2. So there's my solution set to that less than example. So let's finish writing out our steps here. So first you have to get the absolute value by itself. Then you want to stop and analyze which type you have, because it's very different how you handle a less than problem than how you handle a greater than problem, because it's looking at two different situations, where the dog can go or where the guy can go. Two different situations here. So stop, analyze type. So whether it's less than or greater than, because that's going to point you to which column you're looking at. And then you solve the inequality. Okay, let's see if we can do that with a greater than example. Okay, so let's see if we can solve this greater than example here. So if I look at my steps, first of all, I want to get the absolute value by itself on one side of the inequality. So I have 3 times the absolute value of x minus 4 is greater than or equal to 21. So that 3 is a problem. I don't like that my absolute value is multiplied by 3. So how do we get rid of that? Well, to get rid of multiplying by 3, you have to divide. So we're going to divide by 3. We have to be fair on both sides. So there we go. We're dividing both sides by 3. It cancels out that 3 that I was trying to get rid of. So on the left side, I have the absolute value of x minus 4 is greater than or equal to 7. So now we need to stop and analyze this. We got to think about this. Absolute value tells you distance from 0. So if I want to stay 7 units from 0, I want to stay greater than or equal to 7 units from 0. So I need to stay more than 7 feet away from the doghouse. Who are we talking about here? Who is this? Who needs to stay more than 7 feet away? Well, that would be the guy, okay? So he doesn't want to get bit by the ferocious dog. So he has to stay more than 7 feet away. His distance from that doghouse better be greater than 7 feet if he doesn't want to get bit. So where can he stand? If he wants to stay more than 7 feet away, is there any safe zone for him down here on the left? Is there any place he could stand and not get bit by that dog that's on a 7-foot chain? Yeah, if he stands down here to the left of the -7, he'd be safe. What about over here on the right? Is there anywhere he could stand here? Well, if he stands over here, as long as he stays to the right of the +7, he'd be safe there too. So let's get those documented. So this is how you do greater than. You say whatever's there, whatever's inside your absolute value, could be less than or equal to -7. That's how we say we're staying farther to the left of -7. That's one safe zone. Or the other possibility is that we could stay to the right. The symbol for to the right is greater than or equal to, in this case, the +7. Okay, now let's look at what junk I have hidden under that pink sign. Well, that's an x minus 4. So our 2 inequalities we're going to solve here are, here's one of them, x minus 4 is less than or equal to -7. So let's go ahead and solve that while I'm thinking of it. Add 4 on both sides. Those cancel. So x is less than or equal to, that would be -3. So that's one solution set. The other part, so what's under this pink card was an x minus 4. That's what was in my absolute value. Notice I'm not writing the absolute value signs anymore. I already did that by splitting it into the two problems. Greater than will always make you split it into two problems because there are two regions where the guy can stand safely. So anyway, I got to finish solving this. There's a -4. I'm going to add 4 on both sides. So x is greater than or equal to 11. I forgot to graph the simple version of this, so let's go ahead and graph that solution set. So -3, 0 is about there. I think that was 11. So we want x is greater than or equal to 11. So that's that section of the number line, or x is less than or equal to -3. So those are my solution sets for x. Okay, so the last thing I need to tell you about are the two weird cases that you can encounter in these. It has to do with the fact that absolute value means what again? Distance from 0, yes. And do we talk about distances as negative numbers? No, it doesn't make sense to say that like, oh yeah, I just walked -2 miles. What? No, you didn't. So there's two weird cases that can come up with this. So let me show you how to interpret those. One is, here I have the absolute value, so the distance from 0 of this stuff is less than -2. So how can you be less than -2 feet away from something? What's the smallest distance away from something you can be? Well, 0. Like if you're right there, like if I'm at school, my distance from school right now is 0 because I'm here. So to be less than, have your distance be less than a -2, that doesn't even make sense. You can't even do that. So that would be no solution, because how can you have a distance that we measure in positives be less than a negative? That doesn't make sense. The other thing that can show up that's weird with these is, what if I say that my distance is going to be greater than -2? Well, aren't distances always like 0 or larger, like 0 or positive? So isn't a distance always going to be more than -2 feet away from something? It's a weird way to say it, but like even if I'm right at school, aren't I more than -2 feet away? It doesn't even make sense to say it, but every number is going to be more than -2 feet away because distances we always say is positives. So this is all real numbers if you have this weird case, because your distance is always going to be greater than a negative because distances are always positive and positives are always bigger than negatives. So this would be all reals. If you wanted to use your fancy R symbol there, you could. I suppose I could have put no solution over here like that. So, all right, I think that is everything I need to tell you today. So remember that Jesus loves you and so do I. So do your math.